Hey everybody, I thought I would make an answer key for this review here. We're doing a quick retest of A2 and A3, but we'll also probably retest the A4 to A5, A6 material. So here's a little review of all of the above. It didn't have an answer key when I assigned it, so I had to make an answer key anyway. So here we go. Let's get an answer key for this going. Alright, let's start with number one. How do I do that? Well, first thing I do is I look for the biggest possible perfect square I can find in the number 72, and it turns out 72 is actually 36 times 2. And x squared's already a perfect square, and y to the power of 5 has a y to the power of 4 times a y in it. So the things that are perfect squares, here, here, and here, all come out of the bracket and become 6x and y squared, and what remains in the bracket are the things that aren't perfect squares, the 2 and the y. So that's number one. Number two, I'm doing the exact same thing, only now I'm looking for perfect cubes. And in the number 81 is a 27, which is 3 cubed. And x cubed is already a perfect cubed. And y to the 7 is a y to the 6 times y. And if you think about it, y to the 6 is a perfect cube. It's y squared times itself 3 times. So once I get them out of the bracket, I'm going to have the 27 become a 3. The x cubed is going to become an x. The y to the power of 6 is going to become a y to the power of 2. And then inside the cube root, I still have a 3 and a y. Okay, moving on to number 3. For number 3, I have to think about simplifying all of these and then collecting any like terms. So to me this is 2 times, and then in the number 18 there's a 9 and a 2, and x to the 4 is already a perfect square. And then there's nothing I can do with 8x squared at the moment. Same thing with the root of 7 that's on it. The 63, however, has a 9 in it, so this is the square root of 9 times 7 times x to the 4. So when I take the perfect squares out of that radical, I get 6x squared root 2 plus 8x squared root 7 minus 3x squared root 7. And I notice that these two terms are alike terms, so my final answer is 6x squared root 2 plus 5x squared root 7. And there's nothing else I can do with that, so that's my final answer. Next, I'm going to expand this by multiplying it out. Okay, so remember the FOIL process. First times first would be a 3. Outside times outside is minus 2 root 21, but inside times inside is also minus 2 root 21, so together that's minus 4 root 21. And last times last is actually going to be plus 4 times 7. So I have 28 here and a 3 there, making 31 minus 4 root 21. Okay, so that's number 4. Number 5. The smart thing to do here is to try to simplify it before I try to rationalize the denominator. So I kind of think about this actually as that. So I'm going to draw that down as 4 over 3 root 2. And I rationalize the denominator by timesing by 1, which in this case my 1 is a root 2 over root 2. And that gives me 4 root 2 over 3 times 2, which is 6. And I'm still not quite done. I should recognize that that's a simplifiable fraction there. 2 goes into both of those numbers. So my final answer is 2 root 2 over 3. And for number 6, to rationalize this denominator, I'm going to have to multiply top and bottom again by 1. But this time my 1 takes the form of the conjugate of that denominator. Okay, so now we multiply this out, and again, first times first is going to be 4 root 2. Outside times outside is 20 root 3. Inside times inside is 4 because it's 2 times 2. And last times last is going to be 10 root 6. And the denominator is going to be 2 because it's the first times the first. I don't have to worry about the outside and inside. I know those will cancel. That's what a conjugate does. And then last times last is going to be minus 25 times 3. So my final answer. I look across the top, and you know what? There's nothing there that actually combines. There's no like terms there. So my answer for the top is 4 root 2 plus 20 root 3 plus 4 plus 10 root 6, all divided by negative 73. Now there's really nothing much I can do with that. I could rearrange the terms on the top. I could take the negative and factor it or distribute it through the numerator, but it wouldn't really change anything. Certainly wouldn't make it any simpler, so I'm just going to leave it like that. So there's the first page down. All right, one of these guys. So the first step when you're doing these is to make sure that you isolate one of the radicals. I'll isolate the one that's on the left. So this is going to be, move that down a bit, 2x plus 3, and then I'm going to move the 5 to the other side of the equation, and I'm going to get 6 minus 5, which is plus 1. Now my job is to square both sides of the equation. Well, the left is pretty easy. When you square a square root, you just get the thing inside of it. But the one on the right-hand side is a little more work. I'm going to have to square the first term, then times the two terms together and double it, and then square the last term. Now I have to repeat what I did in step 1. I have to isolate this radical. So I'm going to move the x to the other side, leaving me 1x over here. 1 plus 1 is 2, and when I move that 2 to the other side, this becomes a minus 2, so that's 3 minus 2 is 1. And then on this side, I still have 2 root x plus 1. Now I have to, again, square both sides. The left is going to be x squared plus 2x plus 1. The right side is going to be 4 times x plus 1. All right, that's a quadratic equation. The way that we solve quadratic equations is to get everything to one side. I'll do that in a couple of steps here. First, I'll distribute that 4 into the bracket. Then I'll move everything to the other side. So that's x squared minus 2x and minus 3 equals 0. And then you always check to see, does that factor? If it doesn't, you could break out the quadratic formula. But this does happen to factor. X minus 3 and x plus 1 is my two factors. So then x would equal 3 and x would equal negative 1 are my two answers. But I do have to check to see if those answers actually exist or if they're extraneous. So I'll check the first, the x equals 3 first. So the square root of 2 times 3, which is 6, plus 3, plus 5 has to equal the square root of 3 plus 1, which is 4, plus 6. All right, well, that's the square root of 9 plus 5 is equal to the square root of 4 plus 6. That's 3 plus 5 is equal to 2 plus 6. And yep, both sides equal 8. So that is a real answer. That one works. Let's see if the other answer works. Let's check the negative 1. So the square root of, going up here, oops, sorry, you can't see that, 2 times negative 1, that makes negative 2 plus 3, and then that plus 5 has to equal the square root of negative 1 plus 1 plus 6. All right, well, let's see. 3 plus negative 2, and that over there is the square root of 0, and that's 1 plus 5 is equal to 0 plus 6, and that one also works. So nobody's extraneous. Both answers work. Okay, so that was number 7. Now we move on to our rationals unit. And first thing, all we have to do with this thing is figure out what the non-permissible values are. And the first thing to do when you're doing that is to factor. So I can factor the top too while I'm at it, which is that. And I can factor the bottom, which is 4x and x minus 3. And remember that my non-permissible values are anything that would make a factor in the denominator a 0. So if this x was 0, I'd have a 0 times something, and if this x was 3, I'd have a 0 times something. So my non-permissible values are that x cannot equal 0 or 3. Other than that, there is a nice cancel here. So I get x minus 3 over 4x as my final simplified answer. All right, perform the following operation. Okay, well, again, the way to start this is to factor everything. So I'm going to start by factoring the top. The top is going to be y minus 9 times y minus 8 over, and the bottom factors to y minus 3 times y minus 1. I know that dividing is the same thing as multiplying the reciprocal, so I'm just going to flip this over as I factor it. And y squared minus 9, that's a difference of squares, so that's going to make conjugate pairs. And the top, which is now my denominator, factors into y, let me think about that one for a sec. Oh yeah, minus 9 and y plus 3. Okay, there are some factors that cancel here. That one cancels that one, that one cancels that one, and that one cancels that one. So I am left with y minus 8 over y minus 1. Now this question just said to perform the operation. It didn't ask what the non-permissible values were, but if it had, I'll just do them just to show you. If it had asked what the non-permissible values were, remember that this, and this, and this, and these guys here all have to be considered because they were, the ones up here used to be denominators, and you can't divide by 0 at any point of the process. So my non-permissibles are that y cannot equal 1, that takes care of that one, 3 or negative 3, so I'll just say plus or minus 3, and it can't equal 9 either. There we go, I think that takes care of all of them. Okay, of course it didn't ask for that, so if on a test it doesn't ask, you don't have to do it. Number 10, perform the following operation. Well, I can only do this operation if I have a common denominator, and the lowest common denominator here will be x minus 9 times x minus 12. So I have to times this fraction by the part of the denominator that's missing, which is the x minus 12. By the part that it's missing, which is the x minus 9, and that puts it over an entire common denominator of x minus 9 times x minus 12. Okay, let's see if this simplifies any. The top's going to be 3x squared minus 36x minus 2x squared plus, watch the sign on that one, 18x, and that is all over my common denominator. And I can simplify that a little bit. The top is actually going to simplify down to x squared minus 18x. The denominator is not going anywhere. X minus 9 times x minus 12. And you know, I do look at the top and think, if I factored anything, could I cancel one of the factors in the bottom? And the answer is no. All I could factor out of the top is an x, and that wouldn't match any of the factors in the bottom. So I'll just leave it like that. I don't need it any simpler. Okay, and that takes us to the next page, which is an equation to solve. Okay, now, how do we solve these equations? Well, for starters, again, we involve the lowest common denominator, which in this case, the lowest common denominator is x minus 3 times 2x. So what I can do here is I can multiply each part, each term, and there's 3 terms here, by that lowest common denominator. So I'll actually show the whole thing. I might not do this much writing if I was just doing this for myself, but here's the way it would look. I'm going to multiply x minus 3 times 2x times this entire first term, and then I'm going to multiply x minus 3 times 2x times this entire second term, and then I'm going to multiply x minus 3 times 2x times the last term. All right, what does that accomplish? Well, it actually makes all the denominators go away. So that cancels that, leaving me 2x times 21 minus 5x. That cancels that, and while we're at it, those two cancel. I guess I could have done that in the first place. But that just leaves on that. And over here, this 2x cancels that 2x. So I have minus x minus 3 times x minus 2. Okay, I'm going to be very careful with this because of this negative. So this is going to be 42x minus 10x squared. And this is going to be 2x minus, and again, I'll do this FOIL out first, and then I'll distribute the negative, so I'm not trying to do too many steps at once. X squared minus 5x plus 6. Then, let's get rid of that negative. Let's distribute it through minus x squared plus 5x minus 6. Okay, it's a quadratic equation, so again, the way to solve that is to move everything to one side of the equal sign. So if I add x squared to both sides, I get negative 9x squared. If I minus 5x, oh sorry, there's a 2x and a 5x, so that's 7x. If I minus 7x from the 42x, I get 35x's. And there's a constant of minus 6, so I'll add 6 to both sides. I don't like dealing with a leading negative there, so I'm going to just divide the entire equation by negative 1. There's nothing wrong with that. And that's my my equation. Now, I've already worked this out before, and I actually thought at this point that I must have made some sort of mistake, so I went back and looked through my work, because usually these end up being factorable, and this does not factor. 9 times 6 is 54. There are no numbers at times to make 54, not whole numbers anyway, that would add up to make negative 35. So I actually did break out the quadratic formula for this, which you don't usually have to do in these problems, but remember that is a tool in your toolbox. You know that the quadratic formula is minus b plus or minus the square root of b squared minus 4ac all over 2a. And I worked that out, and it doesn't work out very pretty. 35 plus or minus the square root of 1,441, and no, unfortunately that is not a perfect square, all over 18. And I did run a check with my calculator. I actually took this and I plugged that for x back into this expression, and it does work. In fact, both the positive and the negative both work. There is no extraneous answers here. Hopefully on the test you won't get one that works out that ugly. Chances are at this point here you would have been able to factor. Anyway, that was the review. Good luck. Any questions? Come and talk to me.